Cable modem. Think of the cable modem as the critical translator between your home or office and the vast network of the high-speed internet. While a router manages your internal traffic, the cable modem is the device that connects you to the outside world using the same coaxial cables that deliver television signals. To truly master this device, you must understand the DOCSIS standard, the process of signal modulation, and why the shared bandwidth nature of cable impacts your performance. The translator, modulation and demodulation. The word modem is actually a combination of two words, modulator and demodulator. Your internal network uses digital signals, simple ones and zeros traveling over Ethernet or Wi-Fi. However, the long-distance network of the cable provider uses analog radio frequency signals. The cable modem acts as the bridge between these two worlds. When you send an email, the modem modulates your digital data into an analog radio signal to travel out to the street. When you download a video, the modem demodulates the incoming analog signal back into the digital bits your computer understands. The global standard, DOCSIS. Every cable modem follows a set of international rules called DOCSIS, which stands for Data over Cable Service Interface Specification. Over the years, this standard has evolved to provide faster and faster speeds. As a technician, you must pay attention to the version number. DOCSIS 3 introduced channel bonding, which allowed modems to use multiple cable channels at once to increase speed. The more modern DOCSIS 3.1 and the brand new DOCSIS 4 use even more advanced math to provide multi-gigabit speeds that rival fiber optic connections. If a user is complaining about slow speeds despite paying for a high-speed plan, the first thing you check is if their modem is using an outdated DOCSIS version that is bottlenecking their connection. The architecture, a shared medium. The most unique thing about cable internet is that it is a shared medium. Unlike a DSL line or a dedicated fiber line, you share a single physical cable loop with your neighbors in the same block. This is often called a bus topology in the street. Because everyone is sharing the same total capacity, you might notice that your internet speed slows down slightly during the evening when everyone on your street is home and streaming movies at the same time. Modern DOCSIS standards minimize this effect, but it remains a fundamental difference in how cable networks are built compared to other technologies. Security and provisioning. From a cybersecurity perspective, the cable modem is the demarcation point, or demarc. It is where the service provider's network ends and your private network begins. Every modem has a unique physical identifier called a MAC address. When you sign up for service, the provider provisions your modem by looking for that specific MAC address. They send a specialized configuration file to the modem that tells it exactly how fast it is allowed to go. Because of this, you cannot simply swap a modem from one house to another and expect it to work. The provider must first whitelist the new hardware in their system. Troubleshooting, signal levels and lights. When the internet goes down, the lights on the front of the modem tell the whole story. Typically, you want to see a solid power light, followed by solid downstream and upstream lights. These indicate that the modem has successfully found the radio frequencies on the cable. Finally, the online light confirms that the modem has been authenticated and is talking to the provider's server. As a technician, you will often check the signal-to-noise ratio, or SNR, if the coaxial cable in the wall is old, or if there are too many splitters behind the TV, the signal can become too weak or noisy, causing the modem to lose its connection or constantly reboot. By mastering the modulation process and the evolving tiers of the DOCSIS standard, you will be prepared to manage the primary gateway that powers most modern residential and small business internet connections.